Okay, so what I want to do now is go through a little more functions. So we started our discussion on functions by just looking at some ones we already used and had seen before, except this time I've done a little bit more explaining. Here, recall, we said that the input is a function that ironically has no input into it, so we just leave the parentheses with nothing between it. But this function is going to basically operate by going to a console, waiting for a user to input something, and then taking that piece of information and storing it into the variable t input. We then pass that input itself, that data rather, as input into another function, which is the str function, which we have as t input. And then last week we printed that out. Now, if you try to do math on that, okay, let's say +1. All right, you're going to see that it's giving you an error, okay? However, let's try this again. And let's say that we grab some input, but this time we input a number, okay? And so suppose that number that we input here, let's just run this input here, is, I don't know, 2. So t input, if we ask what's in there, the number 2, okay, life's good. And now if we try to run that, whoops, if we try to run that again, what just happened? Try that again, Alt-C. Okay, now you'll see that it automatically inferred that the input is a piece of text. And let's look at another function that we used earlier, which is the type function. Type takes as input a variable name, and it gives you back what data type it is. Now, Python will try its best to kind of guess what the type actually is. And as you can see, it is indeed here an integer. Now, if you were to do t input, let's say str, right? And we run that, and then we run the type on t input. Let's just, for consistency, keep that there. Okay. Now you can see the type is string. And now if you try to add, Python most likely is going to yell at you. And this is true, it's going to yell at you, despite the fact that the number 2 is currently stored in that variable. So what's the moral of the story here? The moral of the story is that when working with variable types, sometimes Python does a good job at inferring what that type is. Other times it just doesn't. So here we have to be pretty careful when dealing with the different data types, at least as input. But anyway, not getting too far into that, the point here is to illustrate the use of functions. So far, we've looked at functions that have no inputs, which happens to be the input function, and functions that have only a single input, such as print, with the string literal passed right into it, or a variable name passed right into it. But what we haven't really looked at are functions that take more than one input, and there's a lot of them in Python. So for example, we have the range function. And the range function, if you plug in, let's say, 1, 4, okay, is for 2 inputs, as you can see, it gives you a list of 3 numbers, 1, 2, 3. If you change that around, change the inputs around, and see what happens, okay? As I mentioned, this is the best way to learn how to use functions. It's just by playing around with the inputs and seeing what you get. So, for example, 3 and 10, so on and so forth. But that's not the only neat part about the range function. The range function, we can also give it a third input and tell it how much we want it to skip by in the list. So suppose we only wanted the even numbers between 0 and 4. or let's say 40, make it more interesting, right? And as you can see, it gives us the even numbers. The first input's the starting number. The second input is the number that we want to stop at, or before rather, at. And you'll see that this skips by every 2. So we start at 2, we start at 0, add 2 to it, we get 2, add 2 to that, we get 4, and so on and so forth. So the range function is a nice little neat function that produces different lists for us. And we'll get back to the concept of lists. But for now, let's focus on functions. So interestingly enough, we do have some mathematical functions, like, so for example, the square root of 16. I can figure that out. Oh, but wait a minute. It's telling me that the SQRT function does not exist, but I know this exists. So why do I get this error then? Well, as it turns out, not all of the functions in Python are contained the minute we open Python up and use it. Python is a very organized, structured type of programming language, as is Java and R and all the other languages. And as like any other language, a lot of the functions are packaged into different modules that we need to load into Python. So think of it like this. We have all these possible functions that we can use, but in order to use them, we need to bring them in from the outside. Now, sometimes this necessitates you to install outside packages, and we will certainly get to that point later in the course. Not today, but later in the course. However, if a package is already installed in Python, then the only thing you need to do is do what's called import it. And the way that we do that is with the command import. So there's 2 ways to do it. I can load a single function, and what I can say is from math import sqrt. Okay, and let's try that. Okay, and now let's try the sqrt function, and lo and behold, you see now it works like magic. Well, it's not magic. Basically, what I said to Python was, hey, there's this function sqrt that I want to use. It's in the package math. So from that package, can you please import sqrt? Now, if you want to import all of the package math, because math has a lot more functions contained in it, what you could do is just say import math. And lo and behold, you're good to go. So for example, there's the tangent function. And we know that the tangent of, let's say, pi, which is roughly, let's say 3.14, is going to be, that's going to be, what is that? The tangent of pi, I'm sorry, not pi, pi over 2. No, I wanted pi, I'm sorry. The tangent of pi, which has a sine of pi, is 0. Cosine is -1, so we should actually get 0 here, or something very close to 0. So as you can see, we're using functions just as before. I give it the function name and I give it some input. The input can be a variable, a string literal, a numerical literal, or any other combination thereof. As we'll see in a moment, vectors and other things that you can do. Anyway, let's see if we can load that. And it says tangent's not defined. What's up with that? Well, as it turns out, we can't use the name TAN despite that being the name of the function. When we don't import an exact function like how we did here with the square root, then what we need to do is first put the name of the package that we imported, a period, and then the name of the function. And as we can see here, okay, we get something somewhat close to 0. But what if I wanted a better approximation of pi? Well, as it turns out, there is a pi. And what we could do is use that. but it says pi doesn't exist. That's because, again, remember, if pi is in the package math and I imported the package, then I need to use the package name. So here it would just be math.pi. If you highlight that and see what value that is, you'll see it's something relatively close to there. And here you'll see we get something ridiculously close to 0. But anyway, now you'll see some tutorials floating around out on the internet and possibly even the textbook. I can't remember if they do this, where they import all the names of the functions without having to do the math dot. I don't like this technique because things can get confusing very quick. So the reason is that if I'm working, when you're working in a productive environment as an analyst in Python or even in R, you'll notice very quickly that some packages you're working with have functions with the same name in it. And in those instances, you need to be very careful with not repeating the same functions with the same names, because Python or R or any other language for that matter, they're going to get confused with which function you're trying to use, and as are you, by the way. So it's always best practice to leave it as is, even if you want to rename the package. I think, if I remember correctly off the top of my head, what you can do is rename it by doing as m, or as any other name you want to give it. And then if you do this, we see that that's still loaded, but now I think I could just use m. Yep, and there you go. So you can sure interchange the name of the package temporarily by using this as, and then you give it any name you want to. And now, as you can see, I can shorten up the names here when working with the functions. Can you theoretically import all the function names? Yes, but it's best practice to not do that and to keep the package names separate from each other. So this way, everything is very clear and consistent. By the way, if you need help, I believe there's a help function here. So if you are confused about what a function does, you can pass the function through a help. You can pass the name of the function through the help function, and the help function will give you some it will give you some information about that variable or about that function. So here it seems like it didn't really give us much information.